Hello and welcome to today's video. Today's video is for Advanced Geometry Chapter 10, Section 6, Circles and Arcs. So we have a lot of definitions in this section. Make sure you pay attention because most of it is familiar, but some of it, like arc measure and arc length, is probably new. So the first thing we have is the definition of a circle. A circle is a set of all points equidistant from a given point called a center, and it has to be in a plane because if it's in space then it's a sphere. So in a plane it's a set of all points equidistant from a given point. Naming a circle, you can name a circle by its center. So I can call it circle P, or I can also use a symbol for it, a little circle with a dot in it, and P. So this circle over here could be called circle P. A radius is a segment that has one endpoint at the center and the other endpoint on the circle. Two circles are congruent if they have congruent radii. So if we do proofs on Chapter 12, which we'll do, if you want to prove that two circles are congruent, all you have to do is show that their radii are congruent, and then you have congruent circles by definition of congruent circles. Concentric circles are circles that lie in the same plane and have the same center. So if I draw one circle, call him circle O, any concentric circle would be a circle that also had a center O and was in the same plane. Okay, so those both would be circle O, and they are concentric circles. A diameter is a segment that contains the center of the circle and has endpoints on the circle. And a central angle is an angle. Should be an N in there. A central angle is an angle whose vertex is the center of the circle. So if you take a look at the picture we have up here, a central angle would be APC. So that would be a central angle. So the example here to learn about how people spend their time, research, study the hour-by-hour activities of 3,600 people, and they were between 18 and 90 years old. Some of the information from the study was shown in the circle graph. What's the measure in degrees of the central angle used for the entertainment? Okay. So if I take a look at entertainment, it says 18%. So what I have is I have 18% of a whole circle, and a whole circle is 360. So I can do 18% or 0.80 of 360. And that can give me my angle measure. So I get 64.8 degrees. And that's going to come into a lot of our area formulas for sectors and parts of circles. Is the fact that we can take the part of the circle we have and then we can multiply it by what the whole circle would be. We also have a semicircle, which is half of a circle. We have something that's called a minor arc, and this is an arc that is smaller than a semicircle. And we have a major arc, which is larger than a semicircle. And then I put the definition of an arc off to the side. An arc is a part of a circle. You can use 2 or 3 letters to name an arc. If you only use 2 letters to represent the arc, then it has to be a minor arc. Okay? So for example, down below, if I say arc AC, then that would have to be this arc that only goes from A to C, and it would be the minor arc. But if I say ADC, then that would be the arc that went from A all the way around through D and then finally to C, which would be that arc right there. So those would represent 2 different arcs. Okay, so in my picture identifying some things, some of the minor arcs. So AC would be a minor arc. Notice we put that little arc sign above it. CE would be an arc. DE would be a minor arc, and AD. Okay, now it doesn't matter if we call it AD or DA, it's the same. Okay. And those are the only minor arcs I have. If I use like DAC, because DC is a diameter, then that would have to be a semicircle, which is the next one it's asking. So here are my my semicircles, and I'm going to need 3 letters for these. So I should have 4 of them. I have DAC, so I have DAC, and if I go the other way, I have DEC. And then if I use the other diameter, I have ADE, and if I go the other way, I have ACE. Okay. And then any major arcs that contain point A. So major arcs, I could have DAE, and I'm not going to pick any that would have it as an endpoint where you could argue that those would fulfill this, but I'm just going to pick major arcs that have this point other than one of the endpoints. So I have DAE, and then I can also do CAE. So 2 major arcs. Adjacent arcs are arcs that have the same of the same circle that have exactly 1 endpoint in common. So for example, if I looked up in the picture, I could say that AD and AC are adjacent arcs. And just like segments and angles, I can add arcs. Okay, the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. And then I also have circumference, we've seen that before, is the distance around the circle. Now, before I go on, even though I believe on the next page you're going to see some of these definitions, I want to talk about the difference between arc measure and arc length. Arc measure is the measure of the arc. Okay. So what it is it's basically the same as the central angle. That would contain the same endpoints. Okay. So if I draw a circle and then I put an arc on it, and I'll call this circle O, and I'll call this arc AB. The arc measure of this arc is the same as if I drew the central angle and I found the measure of this angle. The measure of that central angle is going to be the same as the measure of the arc. So basically, if the circle's 360 degrees, they're asking how many arc measures are measured in that arc. So if I make this circle smaller or larger, it's not going to change the arc length or the arc measure, but it will change the arc length. This is the measure of the part of the circle containing the arc. In other words, it would be like if I took this same arc. So I'll redraw it. We'll call him O, and we've got A, and we've got B. So arc length would be if I took this arc right here and I actually took it off the circle and I measured how long it was using a ruler. Obviously, if I make this circle bigger or larger, the arc length is going to change. The arc measure will not. Okay. Now, in order to tell these apart, when I talk about the arc, the measure, I put a little m. So if I say MAB, I'm talking about the measure of the arc. If I just say AB, I'm talking about the arc itself. And then I can talk about the length of that arc. So, formula you know and love, the circumference of a circle is pi times the diameter, or you also can use 2 times radius times pi. I'm going to do the next example in class. So a car has a turning radius of 16.1. The distance between the 2 tires is 4.7. In completing the outer turning circle, how much further does the outer tire travel on the concentric inner circle? So basically, if we have this car and it does a complete circle, how much further does the outer tire travel than the inner one? So here's the book's definition of arc length. It's a fraction of a circle's circumference. An arc of 60 degrees represents 60 out of 360, or 1/6 of the circle's circumference. Congruent arcs are arcs that have the same measure, or in the same circle, or in congruent circles, which means their arc length would be the same. In order to find the length of an arc, what we have to do is we have to take the arc measure, divide it by 360, and basically what that's going to find is what part of the circle we have, and then we multiply it by the circumference of the circle. So you're going to find a lot with these formulas. I don't memorize the formulas because there's going to be a lot of them, and they can get much more complicated than you think they need to be. Basically, for this one, what you do is you take what part, and you times the whole circle. If I have 50% of the circle, then I'm going to have 50% of the circumference. If I have 1/3 of the circle, I'm going to have 1/3 of the circumference. So basically all this formula is doing is, if I know the arc measure, I know the whole circle is 360, so I divide them to figure out what part of the circle I have, and then I multiply by 2 pi r, which would be the whole circle. Really not a complicated formula. Okay, so find the length of each arc shown below. I want to find the length of xy. So if you take a look, the central angle is 90, and so the arc measure will be the same. So this is 90 out of 360, which is not shocking. It's 1/4 of the circle. And so it's going to be 1/4 of the circumference of the circle. Well, the diameter is 16, so it's going to be 16 pi. And 1/4 of 16 is 4 pi. And you should really leave your answer in terms of pi, unless it tells you not to. And so this will be 4 pi inches. Now the second one, if you notice, it's in red, so they're actually asking you for this. So they want to know what part of that is xpy, that's the major arc. So what I have is, I have 240 out of 360, which is 2/3 of the circle. And so I'm going to take 2/3 of the circle, and the radius is 15, so 30 pi. And if I divide that, I end up getting 2 times 10, which is 20 pi, and it's centimeters. So 20 pi centimeters. You could also, if you wanted to get crazy and you'd rather do the smaller, you can say, oh, the smaller one's 1/3 of the circle, and you can figure that out and then subtract it from the total. Okay? And that is it for today's notes. Thank you for watching. Have a great day.